Okay, I think I've got that right. It seems like I haven't got to see you guys in forever. All these little things, like this is why we hate switching computers, right? Somebody that uses this one has gotten PowerPoint set to where it turns off the presenter view on all the presentations. So that's all right. It just takes me a second. So we want to talk about decision making. I've mentioned the history of computing and how programming developed, and that it was really, really pushed by accountants because they had to do all that math and they wanted something automatic to do all that math. So they really, really pushed. So math, calculations are the most important thing really for a computer to do. I mean, as far as the beginning of time. But then really quickly, we run into the need to make decisions. If we're going to do any sort of logical process, we have to make decisions. You guys have to make all sorts of decisions. Getting here in the morning, you know, we look at stoplights. Is it red? We can go. We can't go. Wait, I'm in Springfield. I don't know which is it, but we can't go. And so
that's the truth.
we try to make all of these decisions and do everything the right way. So if we want to have a computer emulate that kind of thought process, do that kind of logic for us, it needs to be able to make decisions also. So we call that decision-making process selection. And we call it selection because we're saying we're using if statements to select which code gets executed. So when we're looking at our decision-making, in almost every programming language, we're going to be implementing if statements. And an if statement is just that. We're saying, if, bless you, if this, then do some things. So that's good for a lot of decisions that we need to make, just that single alternative. You know, if it's snowy in the morning, get your coat. You know, that would be a standard single alternative type if statement. But sometimes we want to have an alternative course of action, and then we'd use an if-else statement. So with an if-else statement, we have two options, dual alternatives. We can either do the code that is associated with the if statement, if the if statement is true, or we can do code associated with the else statement. And then we can get really fancy and have all sorts of different alternatives. So here's a single alternative, sort of the pseudocode type thing. If something is true, then do something. And then we're going to have an end if. So this is a pseudocode example for us of how we would want to specify an if statement in our pseudocode. We want the keyword if. We want the condition. What are we looking at? They use this keyword then. And that if-then structure kind of carries over like from some older programming languages like BASIC and Visual Basic. And everybody just kind of likes the way it works for pseudocode because it gives us kind of a good ending of the condition. You know, we know, okay, that's the end. Because somebody might get pretty wordy in there in that condition part. So if this, then do all these things. And then we want the end if to say, okay, now we're back to just normal stuff that isn't dependent on that decision. We want to continue on with our program and not worry about that decision anymore. So we'd like for the lines of code that are under the if statement to be indented, so it shows up that that's all part of that if statement body. So all that code within the if statement to the end if is the if statement body. Here's a good one. A message comes out, how old are you? We read in the age. If their age is greater than or equal to 18, then we set a variable named eligibility to yes. We write out a message, you can vote, do some other things, and then we end that if statement.
Question on the topic. So in math, we have two forms of the word if. We have if, which is single directional. If this, then this. But we also have if with two F's, which is bidirectional, meaning if this equals this, then this also equals this. Do we have that in programming?
Not until you get into some really scientific, engineering type programming languages that you'll run into that. There are a few languages that have it. I can't remember exactly what, like Fortran and some older ones like that. But I think in general, you just have to implement that logic yourself in your logic.
Only for things where you have to be able to reverse the code and run it backwards, which this doesn't allow.
Yeah, we don't let you do it. That's why anytime I run into those, my brain goes, no, don't think about that. It's crazy. No, it's really good logic. One of the best things that I've seen people do in practicing programming is try to implement functions like that. Like people that are in a calculus class, at the same time they're in this class, if they try to implement some of the formulas in Python as we get going, that really seems to help people get clear in both areas. So they can write that code and see how that formula works. So it's a really good way to get things cleared up in your brain. Okay, so what if we have something else? We have an if statement, but we want to do some other things if that's not true. So here we're saying we're going to ask how old someone is, read in their age. If they're greater than or equal to 18, we're going to set our eligibility flag to yes, write out you can vote. Otherwise, we're going to set the eligibility to no and write out you're too young. So now, no matter how old the person is, they're going to get one message or the other message. Notice how in our previous example, they only got a message if they were over 18, right? So now, since we added in the else, they get a message either way. Now, looking at our pseudocode structure, again, our if statement, and then our else clause, and our end if, so that we know exactly when our structure is completed. Now, how would this look in a flowchart? Pictorially, sometimes, again, it's clearer to look at. So first of all, if I just have a single alternative, I'm going to be coming into my flowchart decision-making structure. And my decision-making structure is always the diamond. And from the diamond, remember, I always have two paths, either my yes, no, or true, false path. So in this example, if this condition is true, we execute whatever code is in that symbol. If it's not, we just come to the end of the program and don't do anything. Versus the else clause, here we have our decision-making structure. Is the condition true? Yes or no. And either way, we're going to be doing something. We're going to be doing something different, but we'll be having an action. Makes sense? We want to make sure we're covering everything. Now, we can have multiple alternative structures. This would be where I want to say something like, is the value of the code A? If so, do this. Is the value of the code B? If so, do this. Is the value of the code C? And I just want to keep checking all these different possibilities for one variable named code. In that kind of situation, I can have a decision diamond and say, code, and then I would have some code, a body under there for each possible value that my program might encounter. We could be using all sorts of different codes here. It could be, an age code, a student activity code, anything like that. So, some things to think about, guidelines. We don't have to have an else clause. We saw that single alternative doesn't have it. We don't want to make things up. We don't want to manufacture alternative conditions. Just like we saw a couple weeks ago, we want to keep it simple. Same thing with our if statements. We always want to try to simplify as much as possible. When we're looking at an if statement, the body of the if is executed only if that condition is true. And then we always want to indent so that our pseudocode is readable. And next week, when we start working with Python, Python will force us to do that indentation. So we'll see that happening as we code, no matter what. Okay, so here's a couple of examples. 2 ways to write a test condition. Let's look at this code here. We're writing out this message. Do you have any children? Type Y for yes, N for no. And then we're reading in their response. If their response is a Y, we're going to write out a message, how many, and read in that number. Otherwise, we're just going to issue an end message that the questionnaire is complete. Now let's look at this one. Here we're outputting that message. Do you have any children? Reading in their response. And we're saying if response is not N. Now, which of those is clearer if statement wise?
That's the first one.
The first one. And always remember that anytime we start using a not clause, we want to really look at things and see if that's really necessary. Sometimes it's the perfect thing to do and it fits in exactly. But in a case like this, it just overcomplicates things, can make it hard to figure out, and can kind of cause more errors because we're looking at things sort of backwards there. So I always just say, not, don't put them in. Here's a good example, and I think we could do this one in Raptor. Let's try it. You guys don't have to just sit and watch. Here we've got some pseudocode. We're going to prompt for a cost, and then we're going to prompt for a revenue. We're going to use a variable amount and set it equal to the revenue minus the cost. Then we're going to check our amount after doing that math. And if we have a greater than 0 amount, then we'll set our profit to that and output a message about our profit. Otherwise, we'll set a loss variable to that and output a message. Let's go to Raptor and take a look at how we can do if statements. So I know right away that Raptor's going to be kind of annoying about making me save this. So I'm just going to go ahead and save it. And I'm going to call it Chapter 4, Multiple Alt Example. For multiple alternatives. It is kind of long. Now I'm not going to go ahead and put flowchart on it because we see our icon. We can tell that it's a flowchart. Everybody's getting used to that. You guys are fantastic file managers. Save that. So for our flowchart, we want to declare our variables first. So I think that I'll just put in an assignment statement for our cost. So cost is a number. I want to set it to 0.0. I want another one for our revenue. And then lastly, we had that amount, our kind of answer variable. Now, if I look at this pseudocode, or see if I can get it back to where you can see it. I start thinking right away, how do I want to split this up into sub-programs? And just like the programs that we looked at earlier, before we looked at if statements, we have our input section, our processing section, and our processing section is going to kind of include our output. So let's just have an input and an output. Does that sound good? We can do it however we like. I think that'll work good for this one. So I'm going to use my call. And the first module will be input module. And I would like to create a new tab for that. And of course, Raptor takes me right to that new tab. So I want to ask for input from the user. And in our pseudocode, the first thing we do is write out a message. Well, with Raptor, I don't have to do that. I can use my input symbol to output the message to the user and read in the data all at once. Where my pseudocode, it's 2 separate lines. So the first prompt is going to be enter total cost. I need to put a space there. And then I want to save that data in our cost variable. I'm going to click done. And I want another input. This time, our prompt is going to say, enter total revenue. And we're going to read it into our revenue variable. And let's go ahead and test. At this point, make sure we don't have any errors here. Test as we go. Easy to make typos. Looks like my variables are getting set properly. Over here in my watch area. Everybody okay? Bless you. Now I want another module, and this is going to be our output, kind of our processing and output. So I'm going to use the call statement to create that module. And I'm going to name it process out module. How's that? Because I'm kind of shoving a couple of different functions in there. And yes, I would like to create a tab for it. So in our process and output module, the first thing we need to do is calculate that amount variable. So we're going to set our amount variable to our revenue minus our cost. We always want our income to be bigger than our expenses, right? So let's click done there. So now we have our variable that we're going to use in our decision making available to us. So just like we saw when we were creating our early programs, things have to be in the right order. I wouldn't want to have my if statement before my calculation, or I wouldn't be looking at the right amount variable. But now that I've got it calculated, I'm ready to put in a decision or a selection statement. So look over here in your symbols, and you should see the selection symbol. It's got the diamond. We want to drag it and drop it under that calculation. Now, it's enforcing those rules that you can only have two paths out of a decision diamond, your true path and your false path, or your yes path and your no path. So Raptor's already making us be good there and saying, nope, you can't have any other way to go. Your logic has to be tight within these areas. So in the decision diamond itself, I need to put our condition, and our condition is amount greater than 0. I'm going to double click on that, and that's all I want to put in here. So if I were using a programming language, or if I were writing my pseudocode, I would put that keyword if. But Raptor already knows this is an if. So all it wants is, what do you want me to check for? And we want to check to see if amount is greater than 0. When I click done, then you should see that condition inside the decision diamond. Now, according to our flowchart or our pseudocode, if the amount is greater than 0, we have a profit. So I'm going to grab my assignment statement, and I want to put it on the yes path. So I will use it to set profit equal to the amount we calculated. And then we're going to use an output statement to print it out. So in our output statement, we want to write out the profit is, and they would like to have a $sign, so we're going to go ahead and include that in our string. And then we want to concatenate our profit variable. We're done. Now we could actually run it at this point, and we would only be outputting a message if there was a profit. But Raptor wouldn't care that we don't have a no path or an else clause. Let's go ahead and put that code in. We want an assignment statement. And this time, we want to use a variable named loss. We'll set loss to our amount. And I did not declare those variables in our beginning. It's what?
Pseudocode states negative amount. The loss equals negative amount.
Oh, okay, thanks. Yes. You got a problem?
If you try to set something to a variable that doesn't exist, it just creates a new variable.
Sometimes it kind of depends on how you're using it. Like if you're using it in a calculation, then it'll cancel and tell you about it. But sometimes it'll just, yeah, for these, it'll just create them for us. So we don't really need to declare them. Okay, so we've got our loss is a negative amount. And then we're going to output the message. The loss is in a $sign and our loss variable. And of course, we don't really even need that profit and loss variable. They just want us to do a little bit more work with variables. So let's run it. I'm going to enter a total cost of, I don't know, 500, and let's say revenue of 750. So that one should be profit. And there's my output message. The profit is 250. Everybody get that? All good? Okay, good. And then we want to run it again to check for a loss, because we always want to test all of our possible conditions. So I'll say our total cost was 750 and our revenue was 500. And then we see that the loss was 250. Everybody good? So we'll be finishing up our time with Raptor. We have all these different lizards and amphibians we use in our class here. I don't know why. But I want you to have this background, this being able to think about logic outside of a language. We want you to be able to think of how to solve a problem without thinking about what programming language you're going to be using. And so Raptor kind of gives us that ability to say, this is how I'd like to organize it. I want my logic to be this way. So after this week, you might decide, well, I'm never going to use this again. That's okay. You might decide, I need to clarify how this one algorithm is going to work. So I think I'm going to try to put it in Raptor to get a pictorial view. That's okay too. And I wanted you to have a visual of things outside of a given programming language. Because you don't know what programming language you're going to necessarily use. Okay, back to our beautiful thing here. So we've got our profit and loss, multiple alternative, Raptor flowchart implemented, save that. Mostly we're thinking about these concepts here of what code path we should take. Decision making involves testing a condition, and we have to construct these conditions. So one thing that I'd like you to think about as far as conditional ideas is like a robot. If you have a robot arm that's running the assembly line, as it picks things up, it may have to make decisions about those items that it picks up off the assembly line. Is this a square peg? Oh, I put it in this stack over here. Is this peg round? Oh, I put it in this stack over here. So decision making is elemental to all of the different kinds of automation that we might be doing. Okay, so how do we build these conditions? We saw in our little Raptor flowchart, I said all we need is amount greater than 0 in that decision diamond. And that was basically our condition. So we have to know how to build those things. I just told you what to type in there. But the first thing we're going to have to use are relational operators. How do we compare one thing to another thing? Now be careful with this one, because notice they're called relational operators. Sometimes I'll be like flexible with people on the exam and let them say they're comparison operators. But look, there's really only one that's a comparison operator, and that's the is equal to option. And if I want to check to see if two things are equal to each other in my condition, I'm going to use two equal signs right together. One equal sign is going to change the value of a variable. That's an assignment statement. I can't use that when I'm creating a condition. So instead, I'll use two equal signs to indicate equality. For not equal, most programming languages like exclamation point equal is not equal to, or bang equal, exclamation point. We can use the less than operator, greater than, less than or equal to, greater than or equal to. Remember that the less than or greater than symbol always comes before the equal sign. If we're doing a less than or equal to or a greater than or equal to, we can't swap those. It only understands it in that order. So here's some examples. Let's say we have variables A and B, and A is set to 9 and B is set to 6. Then the if statement, if A is greater than B, right, A plus is greater than B, and if, can be read kind of in an English-like way. And if you kind of read through those statements on your own, it'll help you with it a little bit in figuring out what the logic is. So they say you can read this as, if it is true that the value of variable A is greater than the value of variable B, then write the value of B to the screen. So that sounds good. They do something a little different there in their example, but that's basically what we want. So take a look at these. We have a value of 23 for A and 16 for B. As we go through all of these different conditions, make sure that you're seeing why they're true or false. So is A greater than B? Yes. Is A less than B? No. Is A greater than or equal to B? Yes. Less than or equal? No. Is A not equal to B? Yes, that's true. But they are not equal, so A equals B is false. That's what we're looking for here. We always want a condition that will result in a true or a false value. And then in our decision making, we know what course of action to follow based on that decision. I already mentioned this. If we're assigning a value, we use 1 equals sign 2 as the if statement. So here we're saying set A equal to 14, B equal to 27. In this case, the equal sign is assigning a value. It's being the assignment operator. But here, if we're saying is A equal to B, it's being the relational operator. Take a look at this for a second. What's the difference? Is it going to come out the same?
Almost the inputs are the same.
So just an alternative. What about this one? Differences? What's our differences going to be?
One of them will be equal to or greater than 16. That is true.
The first one should be. So there's a logic error there. It's hidden because that should be a greater than or equal. Mhm. Would not be true, right? So yeah, just that one thing can mess it all up. Good job. It's really can be hard to see those. Okay, so we saw that we have operators that we use to see what kind of relational condition we have between variables, but we can also put different conditions together, create compound conditions, like if A equal B and A equals C. So that way we can make things a little bit more realistic. So a compound condition uses our logical operators and or not. So let's look at examples. I think that's always better. So in this example, they have two that they say are the same. We have if x is less than 5, write okay. If x is greater than 10, then write okay. And then over here, we have if x is less than 5 or x is greater than 10, write okay. So you see how that's going to be the same results there. So that or condition is saying if either one of these is true, the entire condition is true. Now the and operator is saying this one must be true and the other one must be true. So if we don't have both conditions true with an and, our entire condition will be deemed false. Or and then not. Again, the not operator totally just complicates things and makes everything backwards. So if we are looking at a condition and we put the keyword not in front of it, we completely switch it around. So we're saying that the not operator makes the condition true only if the condition was false. Making me say things like that. Okay, and then this is a truth table. This is important for us in thinking about what kind of data we need to test our program, because like I said, we need to test every condition. In this example, we have a variable named X and a variable named Y. Looking at those two variables, let's call them Boolean variables that are only capable of being true or false. Looking at their values, we can determine what the results would be of an if statement that uses a compound condition to compare these. So if X is true and Y is true, and we add them together in a compound condition using an or, that compound condition would also be true, right? If we added them together using an and, because they're both true, a compound condition would also be true. If we used a not keyword in front of them, then the entire thing would become false. Now, the next row down changes things a little bit and says, what if the value of Y is false? In that case, if I combine them using an or condition, I would still get a true for the entire condition. But if I combine them using an and, now my and condition would result in a false, because one of these is false. And my not condition would also result in a false. Now, if the other one, if X is false, we should see the same type of thing. And if they're both false, we're going to get a false return on an or, a false return on an and. And the only way we would get it true is a not condition. So if statement conditions can be a lot of fun trying to decide how to handle all of your logic and what's going to work. So I can use this truth table then to figure out what all test data I need to test with. In this particular instance, I need to test all of these conditions for X with all of these possible conditions for Y, so I can make sure that I've gotten everything tested. All right. Our conditions that we're combining together using these compound conditions have to be kind of separate. So they're showing parentheses around each of those conditions with an or statement combining them. Notice how the X variable has to be mentioned both times. If X is less than 5 or X is greater than 10. I can't shortcut and say if X is less than 5 or greater than 10. I have to have a complete condition, a left operand and a right operand on both sides of my if statement. Okay, here's a nice overtime one. We have this example a lot as we go on. We have some workers here. Let's see, our people who earn less than $10 an hour are paid overtime pay. So that means if they work more than 40 hours in a week, all those hours that they worked more than 40, they get paid time and a half. If they already earn more than $10 an hour, or $10 an hour exactly, then they don't get overtime. They only get their regular time. So we have this nice calculation here for us. So let's set that up in Raptor. I'm going to close my revenue flow chart. Or just create a new one, I guess. And my new one, I'm going to save as Chapter 4, overtime calc. Now for this flowchart, instead of us using an input module and prompting for input, let's just go ahead and assign a value to that pay rate and hours variable to use as our test data. So I'm going to create an assignment statement, and I'm going to set the pay rate to, let's start, we'll say we'll test with a pay rate of 10. And then the other variable I'm going to need in this program, at least for our if statement, is hours. Bless you. So I'll set hours to 40 for this first test. Now in our little algorithm, they have a calculation for us depending on our pay rate and our hours. So let's put a selection statement in this flow chart. And in our selection statement, our condition is going to be a compound condition. So I'm going to use parentheses. I want to know if the pay rate is less than 10 and the hours is greater than 40. So again, notice how Raptor doesn't care about any of that other stuff around that if statement, just that condition. If I have anything wrong, like I missed parentheses or I didn't close one or something, I could get some sort of error on this. So be aware, let me know if you run into trouble so we can fix it. So in our if statement here, we're checking to see if somebody gets overtime or not. So on our no path, let's create it first because it's real simple. I'm going to take an assignment statement, and in my no path, I'm going to say, okay, set total pay to hours times pay rate. Now, on the other side is a little bit more difficult. First, we have to figure out how many hours over 40 they worked. I'm going to drag an assignment statement onto our flowchart. And we're going to set overtime hours to hours minus 40. Now, we're going to go through this one and do it in Raptor because they do use this example a lot in the test bank for our test questions. And I know that all of you guys get ripped off and nobody ever gets overtime anymore, so nobody knows how it works. It used to be an actual thing, but anymore, I don't know. Or young people don't get stuff like that very often. So I figured out nobody knew what that meant. Okay, so now we know how many hours of overtime pay they get. Let's figure out what their overtime pay is. So now you guys know you should be getting this. Our calculation is going to give us overtime pay. And it's going to be our overtime hours that we just calculated times 1.5 times our pay rate. So if you make $10 an hour, your overtime hours should be paid at $15 an hour. Now, in this calculation, do we need any parentheses or anything? Would they make you feel better? The calculation comes out the same either way, but we might want to put some in to say, well, you would really take 1.5 times the pay rate first before you multiplied that by the number of hours. But it comes out the same either way, just to kind of show that logic. Okay, so I'm done on that calculation. So now I can finally calculate the total pay for this overtime person. I will say total pay is going to be 40 hours times our normal pay rate plus the overtime pay we just calculated. So for this example, we're going to we're pulling things back a little bit. The examples we've done so far, we've always included our, prompt for input, write out our nice output. But here we're kind of just testing this one algorithm. So instead of prompting for input, we're assigning our own values to our variables just for testing of our algorithm. And then instead of outputting things, we'll just look at our watch variables and make sure that we're coming out with the right values. So for this one, where we're saying that they get paid $10 an hour and they worked 40 hours, they should just get 400 as a total pay. Let's run it and check. We shouldn't have to do any input. And there we go, it came out 400. So if we want to change that then, what if we say this person working $10 an hour worked 45 hours? Now we can run it again with our new test data. And now we see their pay is updated. Oh, I made them make 10, didn't I? I have to go. We have to change their pay rate to 9. And then they should get overtime because they should be less than $10 for the pay rate. So there we finally got our overtime pay. And if we were looking at the assignment for our algorithm, and they said if the pay rate is less than or equal to 10, then of course we would change that condition to be less than or equal. Is everybody's working okay? Okay, got this algorithm down. Know how to do it. Yay, fun. Okay, so what did they do here? What's the difference? We didn't do it this way. What did they just do?
The or statement.
They did ors, and what else did they change?
I mean, before, which is they reversed the, it's called polarity of the statements. Now,
That's a good
instead
way.
of being because of a positive statement is because one of those two things is not correct. Or I guess, yeah. Hold on.
It should be valid. I think it's okay. Just changing again, like you say, the polarity. I like that way of describing of the comparisons. So all of them are fine.
Except the or doesn't like.
Oh, that would be wrong, wouldn't it?
Yeah, because it does it unnecessarily.
Yeah,
Because
that
if
would be
your-
wrong.
If your pay rate's less than 10, but you still only work 40 hours, it calculates your overtime. It just calculates it as 0 hours. There's no point in doing that.
Yeah, so let's see what they say up here. Workers who earn less than $10 per hour are paid 1.5 times their normal rate. $10 or more, paid their regular hours. So they just, yeah. Sonny mentioned they just have changed it here to where if they, I don't know, we could try it. Looks really complicated, doesn't it? Sometimes when you have that much trouble deciphering something, you say, this is a really complicated way of doing it. So why would we? But yeah, they're changing our requirements too. So that's okay. Always read really carefully when you run into those questions. So let's look at it in a picture and really see what the difference is here. This will be better. We are starting out with our original one that we did in Raptor is our pay rate less than 10, and hours greater than 40. Both of those conditions must be met for us to calculate overtime. In this one then, we're saying is the pay rate greater than or equal to 10 or hours less than or equal to 40. In this situation, only one of these conditions must be met for us to do only a total pay calculation. So in the end, we end up getting the same result because both of those conditions must be met for us to do the overtime pay calculation. But we always do want to clarify things. And sometimes if you look at a conditional statement and it looks really, really complicated and you think you can clarify, remember that's an area that requires a lot of testing. There may be a really good reason that it's so complicated, and you know, your change needs to be tested and make sure that it doesn't cause problems. Sometimes simplifying is really good, but not if it causes trouble. Okay, so we saw, please excuse my dear Aunt Sally when we were talking about doing calculations, order of precedence, right? We have an order of precedence when we're looking at if statement. It's kind of huge. It's a huge order of precedence. So the first thing is the system is going to evaluate any math problems that are buried within that condition. So if we add two numbers or anything within our if statement condition, which we can do, those are going to be evaluated first and the answers are going to be determined. Once all of that math has been resolved, then we're going to start looking at the relational operators. They all have the same precedence, if you see that little note up there. So that means they're just going to be evaluated left to right unless parentheses are involved. They kind of leave that, well, the parentheses are way up here. Now, logical operators are last, are ands, ors, and nots. So after we've figured out this condition is true, and this condition is false, and this condition is false, we'll check the comparison to see how they're supposed to be connected. Okay, what about this one? If Q is 3 and R is 5, is the following expression true or false? Is Q greater than 3? No. Is R less than 3? No. Is Q minus R less than or equal to 0? Yes. So what do we have there? Our first one was, it's really messy. Notice how they did it. As we are looking at those conditions, our first condition of Q greater than 3, we said, no, that's false. Well, it has a not operator in front of it, so that switches its value to true. On the other side of our or condition, we see false and true, so that means that the and condition has to be false. But since they're connected with an or, our final condition is going to be true. So just like working through a math problem, to take it step by step, looking at the conditional code, determining what's going to happen in what order to decide what's going to happen. And as we're developing software, we'll see that we have tools, debuggers, and different tools available to help us with that, because sometimes it can be kind of tough. When we're working with if statements, a lot of times we'll be using Boolean variables. If you remember from way back, Boolean variables only have values of true or false. So we can use Boolean variables in an if statement as a condition without any other stuff. So here I can declare a Boolean variable named answer, set it to value of true, and then do an if statement that just checks that variable name. Because it has a value of true or false, it'll satisfy that condition. whenever we're comparing strings, that's what they're talking about here. Things can get a little bit iffy because computers like things that are totally identifiable, like integers. You know, we can tell really easy if 5 is equal to 5. But when we start having really, really long precision values in decimal places or working with strings, we can have a little bit more trouble. So whenever we're working with strings, we can use our relational operators in just the same way as we do with numbers. But if you remember from chapter 2, we had this ASCII chart, and that's the ASCII code set or Unicode code set. And we actually had it in Canvas. So let's take a look here. You don't have to go to it. I'll bring it up and we can look at it on the screen. But I want to remind you about it because there's a question or two about it. So it's in week 2, ASCII chart. So if I look at this, it tells me I'm starting with special characters up here at the top. I finally get to the character data that we see, and over here we have the binary equivalent of that, our binary encoded value, and it gives us the decimal encoded value and all sorts of great things. So if I'm looking at the letter E, uppercase E, is it less than or greater than the letter F, uppercase F? Look at your code chart, which is which. So anytime you're comparing string values that are non-numeric, this ASCII code chart is what's going to be being used behind the scenes. And yes, it'll be in alphabetical order is what it'll amount to for us. And the uppercase letters will be less than the lowercase letters if you look. So as we scroll through, we should see all of our lowercase letters later. So that's how that sort order will be determined when we're working with strings. It's not. Remember when we're working with strings that they can look just like numbers? So be aware of that. Whenever we're comparing things using if statements, we can have some unexpected results if we're handling our numbers as strings. For example, we might not expect this to be true, but since we're doing string comparison, 1 is less than 2. And then over here again, that would be true because those are not equal. 24.0 is not the same as just 24. So since we're comparing strings and not numbers there, we can get some unexpected results. So we always have to look at all of those little details and make sure that everything is correct. We can also have if statements that are nested within other if statements. This example shows an if statement with an else clause, and then the else clause has another if statement. Now you start seeing why it's so important to indent things. We can start getting some pseudocode that's totally unreadable if we don't keep our indentation on track. Here's one for the voting. If the age is greater than or equal to 18, then they can vote. Otherwise, if the age is greater than 15, our eligibility is maybe. I don't know why. Otherwise, it's no, no way, you don't have a chance. Okay, so some hints. And this is in different programming languages. The number of end ifs must equal the number of ifs. And that can actually be a great big deal. You can draw a line to connect them if you need to check. So sometimes people will print out code and draw lines from their if statement to their else statement to check. I once knew a programmer down the road in Carthage who was super proud that when he printed out his program, it was a giant stack of paper, that if he printed it on continuous forms a long time ago, he was super happy that his if statements went like 22 pages between the beginning of an if statement and the end of an if statement. And that was a really good indication that he should be moved out of programming, because that's a way, way too complicated of an if statement. And nobody liked working on his code, but he was really, really proud. And he would show you, look, and he had color coded to show you how 22 pages worth of if statements. So bad way to do it. They promoted him. That's usually how they move people like that out of programming.
What did the code do, out of curiosity?
It was for the billing system, so it did some sort of major processing based on, you know, who the customer was and all sorts of what product they were buying and giving them discounts based on different things and stuff like that. So it was a pretty complicated system. They really like to, and a lot of companies are that way, where special customers have all sorts of special conditions set up, and it can get really complicated. So yes, he would get out his color-coded highlighters and make sure his end ifs all matched up with his ifs, and then walk around and tell everybody how many pages his giant if statement was now. And we were all like, please get him promoted. We'll have to work with him. What's going on this one? Take a look at it. Tell me what's going on.
Case statement for one.
Uh-huh. What's it look like? Kind of optimistic grading, huh? No child left behind grading. No Fs. You don't get Fs, but other than that, it's a grade.
It's pretty simplified by just saying if score is equal to or less than 5, separate it.
Yes. Because it's like almost overcomplicated. So they say that's the long way. Because it's like Isaiah mentioned. If we could use a structure like a case structure, we might be able to do it a little bit easier. They have some other alternatives here, though. What about this one? Take a look at it. Is it better? Worse?
It's a bit worse because it makes it seem like those are all sub-functions, but they're all doing the same thing.
Yeah, it almost makes you think that the D is dependent on the A or something, doesn't it? Because they're all nested that way. But it works, it's fine, but it is a different way of handling it. In this example, we're using nested if statements. We have if statements within our if statements. So our flow chart would look a little bit more like this, where we're saying, is the score greater than 10? Yes. No. Is it equal 8 or 9? And we're just dropping down into all of those decisions. So that's a fine way to do it. But we have a really advanced structure available called a case or a switch statement. And in a switch statement, we can actually use a specific variable to test several different values within this one statement. So we can say, if this variable equals this value, do these things. If it equals this value, do these things. And we can keep adding additional items there to our case statement to say, oh, if it's this value, do this. So our code would look a little bit more organized, right? So we see they're looking all pretty. So this is called a multiple alternative, meaning that my case statement can look at this score variable and offer up logic to do for many different alternatives. If score is between 1 and 5, we'll give them a D. If score is 6 or 7, a C. So notice how that case statement works.
What's the break? Is that the same as the push break?
Good question. The break says basically, I'm done with this case statement now, go to the end of it. So we'll do whatever we want to do for the A and then break out of the case statement. So we'll go down to the end. Now the case statement is one that we won't be able to try with Python because Python doesn't have it. So this is going to be a hard one to remember because we won't be able to implement it. So if we look online, there are all sorts of things we can do to like get close in Python, but Python will give us some other things that are good that'll make up for it. But using the switch case statement, you might not get experience with that until you get to one of your higher level languages. Here is a flow chart looking at that case statement, where now we've got the value of score, and then we have all of our different values up here as labels in our flow chart, and then what actions happen based on those different values. And then we can use our decision making to defend our programs, to be defensive. And what that means is, some of you have already put some code in, but we can check to make sure that the input we receive is valid data, so that we don't try to do a calculation with non-numeric data, or try to divide by 0, or one of those kinds of things that is illogical. So defensive programming is us making sure the data that we're going to use is valid. So in this first example, take a look at that code and see what they're doing. In this example, they're saying that cost can't be 0, right? It has to cost something. So that's the error message that they'd give out for that. What about this next one? Take a look at it. If our number is 0, we can't use it as a divisor, so we have to say, no, I'm not going to let my program cancel. You're not going to trick me into dividing by 0. We can't do it. So that's what they're checking for on that one. What about this one? So again, we would have an illogical condition where the system would not know how to calculate a square root of 0. So we're just going to keep that from happening. Say no. Now, whenever we're getting done with our pseudocode, we're going to be looking at it by playing computer. Had you guys do that quite a bit, or desk checking. When we do that, we're going to be performing all the calculations multiple times manually or with a calculator to make sure everything is working. And we're going to make sure to use test data like we did to show the results when each branch of each selection structure is executed. So we have a lot of different things that we need to check depending on our algorithm. And then we can use our selection and statements to check for dividing by 0 and square root things and any other sort of special thing that we might run into. Okay, what's a menu-driven program? They're getting kind of old. What would you guys say? Can you think of a menu-driven program that you use?
Mostly in the context of stuff from the command prompt, right?
Yeah, sort of.
I guess every utility I've ever created in my game
Is menu-driven. And if you really think about it, I mean, Netflix is menu-driven, right? You're going through the menus to get to the stuff you want, but it's not character-based. It's more graphical. But they're all menus. That's what we're used to. I mean, we have been trained to use the menu, right? We know, okay, go there, do this, do this, do this. Well, that started out with these old character-based menus. There's one like that. So you'll see that was a legendary lawnmower company. So in the old days, the early days, that was all there was character-based applications. And so we start out programming doing character-based applications like this. So some of the programs that we write at the beginning can be kind of hard for us because they're kind of not really realistic for what we would use right now in today's world. But we go back to this to make them easy, you know, to leave out some of that complication as we get started. So this is what they mean when they're talking about a menu-driven program. So if we wanted to create this menu, we would just have some write statements, right? And we would just write this message, write this message, write this message. And then finally, after we wrote all of these, we would input their choice. And then we would do an if statement. If their choice was 0, go do whatever that menu option is, that module. If their choice is 1, go do that module. So in your textbook, when they're talking about a menu-driven program, this is what they're talking about. A couple years ago, people would say, it's like an Xbox, but I think that even the old menu-driven Xboxes are pretty old now. I don't do those anymore. But we use them all the time for everything. We'll just start out with these character-based ones that aren't quite as pretty as Netflix. It's still the same idea. Whew, thank goodness. Okay, I know that was a tough one. Hate to go through a long presentation like that all at once. But next week, we're going to, since we've had these kind of changes to our schedule, we had to. So next week, we'll start with Python. We'll have our new classroom. So we'll get all logged on and get situated. We'll see if Python works on any of the computers. We'll see if you guys can install it. If it doesn't, we'll just kind of go from there and hope that it works for everybody and all that kind of good stuff. As opposed to, you know, I have actually asked and all those kinds of things. It's hard to know for sure. So we'll look at that. We'll start looking at some training. So if you want to get ahead, the only thing that you have due tonight, again, is those short answer questions for chapter 4. Give you some time to do those. But next week, we're going to start working with a training facility for Python called Code Academy. So let's go ahead and create an account. So I'm going to Google Code Academy. And this is the one I want, Learn to Code for Free. And when you click on it, notice there is no A in Academy, no beginning A in their actual URL. So it's like Code Academy. Took me a long time to find it. So go ahead and set up an account. Now, if you haven't used this yet in another class, you probably will. So you can log in or sign up using any account you want. But if you want to use your OTC account, that's fine too. Now, as you use Code Academy, this pro option is cost. Never, never do those. You know, I mean, you're welcome to if you want to pay or something and do those cost items. But I do not want you to use any of the pro options that are available. So it will keep harassing you about it. You don't need to do that at all. Oops, got to log in, not sign up. So I'm going to go back and try to get out of this pro stuff. Now, if you can find this main screen, it's starting out with today. I'm going to be looking at the catalog. So get your account set up. What we really want to do is look at their entire catalog of training items so that you can see which one you want to use.
Where's catalog?
I think if you click this Code Academy icon, it should take you to this home page, and then you should see catalog. It's also at the bottom of a lot of the screens. Now, the full catalog, Code Academy started out completely free, but it was really nice. So, I mean, we knew that it was probably not going to stay free for a really long time. And sure enough, they've got their money-making plan now. So we have to kind of be careful. Some of the training is free and some of it costs money. Like I said, we're only looking at free stuff. So we're really looking for Python. And if you are looking at this catalog page, you should see by language it even has Python there as an option. I'll just click that. They have a lot of Python options. Wow, there used to be one. So things have changed in just a couple years. And they say Python's the most popular programming language there is right now, which is really wild. Now, we're going to be using Python 3. The versions of Python version 2.7 was really, really popular. Got really accepted. All sorts of people started using it. It took a really long time for them to get people to move to version 3 of Python. We are on version 3. As you see, that training costs money. We're going to have to use the training for version 2. There are only 2 differences, so it won't be a big deal for us to switch back and forth. And you guys will get on top of it in no time. So if you're bored and if you wanted to get a little bit ahead, you could start that Learn Python 2 course. That's the one. Now, I will never ever be asking you to do the whole course. If you look at the overview here, we'll actually do sections 1, 2, and 3 in our class. And all of the rest of the course is just totally optional. I do have an extra credit assignment out there for you if you finish the course, if you want to. Some people like to. All right, questions about the Code Academy thing? Have you used it before? I know in the web dev classes they use some and some of the different ones. We'll just use it a little bit because it gives people a chance to do some individualized training. Do what? No, just the teacher, they won't let you. I wish they would. It would be nice if we could just all use the same thing. I was going to go to those questions at the end of the chapter. I know some of you already have those done. If you want to get out of here, if you want to stay, what I want to look at are some of the sample if statements that they give us. And along those lines, I actually printed out some practice ones. Let's see those instead. Ready for this? Everybody get one? And one extra. So take a look at this, and then down at the bottom, just look at each example and determine whether that would be true or false. Yeah, whatever you want.
we trying to say there for,
Just for us, let's get over it. What's everybody think? Too easy. What's the first one? False. Second one?
Are you going up, down, or are you going?
Ah, thank you. I was like, wait, I'm really worried. He saved me. Okay, third one. Number 3.
That would be.
Okay, number 4. A less than B.
Three is definitely not true. Three is definitely true.
Look at the numbers.
Look at the does not equal, can be greater than, equal than, up at the top of the page. Oh, that's
Yeah, different languages being tricky on you. Yeah, so not equal. Okay, wait, let's go to number 4. A less than B. I agree. What about number 5? 6, 7, 8, 9, 10, 11, 12, 13, 14. Awesome. Get out of here. 6. False. False. Nope, you can keep that or put it in the recycle bin on your way out. Practice. You guys have a great weekend. Next week I get to see you twice. Brutalize ya. Okay.
Number 2.
Okay.
Why is there only one equals one? I mean, I know at the top.
Oh, you're right. It's a typo.
Well, so if you look at the top,
Mhm.
it said that
A equals B. Mhm.
yeah, it gives it something.
No, I'm
to
gonna
do
fix
that,
it. I'm gonna change it. Here I am telling you that and then messing you.
Remove the question that is right and too small.
Mm-hmm. Sure.
Hey.
You gotta stay there and just soldered certain parts like that.
Life dropped my head last Thursday. So I didn't get to do an assignment for the test. I'm not trying to make it up.
Not in my business, but is everything okay?
My son went into the hospital, and I spent most of my day Thursday and all of Friday with him at the hospital and follow-up appointments.
Everything okay?
Yeah. He's only seen a therapist for a little while. Thursday morning, he decided he was going to wrap a tennis chain around his neck at school. And because of what he did, it was mandated you got to go to counselor situation. Yeah. So I just didn't do anything.
Well, let's just set you up as a retake at the test center for the test part. And Vincent, if you go ahead and do that hands-on exam, I'll dock you a little bit for being late, but I'll take it. Okay. Same thing.
Yeah.
Let's fix you up. Okay, so what I can do is I'll set it up at the test center as a retake, and you can just go over there and take it. So today is Thursday?
Yeah,
right?
today's Thursday.
Could you take it today or tomorrow? Maybe tomorrow?
Yeah, I could go in there after 5 either day.
Because I think they're open that late. So
I
it would
think
just
they're open
depend
until
on-
8.
So you should be fine.
Yeah.
So what I'll do is I'll set it up through them, and so they should have the paperwork when you get there. So
Worst case scenario, I need to get in there before 5. I'm going to talk to my boss. I'm doing work study over at Grant Hall.
oh,
I can go talk to Matt, and he'll be like, "Oh yeah, go take your test and then come back." So
okay. That would be awesome. Yeah, so just do that same thing. Go ahead, turn in the hands-on, and I'll just dock a little bit for being late.
yeah,
We'll
I
just
don't
go
mind
that way.
missing points because of something like this. I just wanted you to be aware that I didn't just blow it off to blow it off.
Well, I was worried because it was super noticeable. Group because we have a really good class this semester, and so anybody, everything's okay.
Yeah.
Concerned, you
I,
knew that wasn't normal.
It didn't even cross my mind to email because
No, you had so
everything
much
going
going
on.
on. I know.
was like,
That's just totally understandable. when you
So,
have that much going
hospital,
on.
I was actually signing paperwork to buy a car when we got the phone call. So I'm juggling between finishing the paperwork for this car, getting to the hospital. Thankfully, my wife was able to just
Good.
go get them.
Mhm.
So I finished up everything, and I'm like, okay, I'm gonna leave the car here, and I'll come and get it after we're done with everything. I had to call a good friend of mine around 11 o'clock that night to come meet me so that we could drive my current vehicle, the new vehicle home. Friday morning, my wife and I were in appointments with him all day, follow-ups, all sorts of things like that. Saturday and Sunday, I had to be in St. Louis on business. So, and then we've got this newborn that we're dealing with too. It just.
So is that having an impact on him?
The newborn's not really affecting him. We're a blended family.
Mhm.
His biological father hasn't called to talk to him in 3 years. And I'm dad,
Mhm.
he's Scott. And, he wants to talk to Scott, but Scott's not even making an effort to call. So that's a lot on him.
Mhm.
And then my grandmother passed away back in October. He met her once. It was never any effect on him. But my mom had gotten real sad here recently because they're getting ready to hold a memorial for my grandmother. And I guess he asked my mom what was wrong. And my mom told him, and then he started thinking about my wife's parents, which would be my grandparents he knew, aside from my parents. And he got sad because he missed them, and that's when he wrapped his death. He wanted to go see them, was what he said.
Oh,
And it just was. So
how tough. Yeah.
we're doing therapy of referral for him. We're going to be keeping up on that for a little while. My oldest daughter did this. She was a little younger than he is currently, and she did this, but she did it with a pair of scissors. And she was actually in the hospital for a good week because of it. 9-year-old.
Same mom.
No. The oldest girl was with my first relationship, and my ex and her, they get along like cats and dogs. That constantly fighting. They are either perfect until something goes wrong, or they're fighting from the moment they see each other. And I don't know what happened, but she got fed up with it. Just was like, okay. At 9 years old, I just blows my mind. I have no idea why people would do that. Even at my age, much
Right.
less that age.
Well, and I know when I grew up, it was not something that I knew about. You know, I mean, literally, that wasn't information that we had. I didn't know that was something.
My Uncle
Just know
John,
so much more. Already, you're already done. It's like, dunk, okay.
So I've got it submitted, so that way.
You're good. Thank you, sir.
my Uncle John, he committed suicide in '74,
Mm-hmm.
and as far as my mom's side of the family is concerned, it was an accident.
My Uncle John was the same way.
Yeah,
How weird is that, huh?
yeah. It's. I
My
know.
Uncle John was president of the Allstate Insurance Company in Chicago. So you bet it was an accident.
Yeah.
All the way around. My other uncle told me he said he went to the coroner and he bribed him to write accident. And it didn't have an impact on the insurance. It wasn't that.
Yeah.
It was just the
Well,
thing for the family and all that kind of stuff. You know, he felt like. So my cousins, they know what happened, but he had been drinking really heavy, so they really hang on to that accident story.
Well, and I think for my mom's sisters, it really helps.
Did it help them? Yeah. You know, I mean, it's helpful for the people that are here, and those are the ones,
And
you know, because those ones sadly chose not to be, you know.
my mom, she knows what happened, and she's accepted what happened.
Mm-hmm.
John was not having a good time when he came back from whatever war zone he was in,
Mm-hmm.
and he got a real bad heroin problem.
Mm.
And he just couldn't cope.
Mm-hmm.
We had a neighbor growing up that was in a similar situation. He went to Iraq in '91, and he got captured and was POW for a few months. Well, he contracted AIDS while he was a POW because of bad things they were doing, and he couldn't keep up. And he found needles, and that's what got him.
Uh-huh.
And I guess I grew up with this, you know, knowing that people did this. It was a different time, you know, in '80s and '90s. We were dealing with all these people that were coming out of Vietnam, coming out of Iran, and then in the early '90s we had Desert Storm Shield. Just a big deal that we had to learn to deal with. And then I feel bad for these kids that are half my age that they've never known us at peace.
No, it's so hard to understand what they know. It's like the overtime pay thing. The first semester I realized they had no idea what overtime pay was.
Yeah.
Because they get great the job they get.
Oh, I know.
And then these people just talk about how awful they are. It's like, can you believe you guys? They really have it. They've always been lied to. They have so much information. It's so way too much to promise.
Oh, yes. Yeah.
So, hello. Question.
What are the chances that you might extend the due date on that homework?
Oh, I'm going to. That's what I'm going to do.
Cool.
Thank you for reminding me. I had somebody ask, so I was like, sure.
We have
That's
an
fine.
exam in our next class period, so I'm like,
That's
I use my breaks to
fine.
study for that. So I'm like, I need to take notes and I need to.
I just feel bad. Last semester, I kept changing stuff because we had all sorts of calendar issues too. And I finally had this one guy that was like, are you going to keep changing due dates? Because I keep having stuff done. And I was like, I'm trying not to. I always try not to. And that class, I just was like, that's why so many of our due dates are Thursday, because I always had them Tuesday. And last semester was just like, we had missing days and things. And I was like, well, we have to move all these to Thursday because nothing's working on
Yeah.
Tuesday. So we'll move
I-
this one to Tuesday. How's that? To Tuesday. Tuesday, Thursday,
Yeah,
Tuesday,
I'll
Thursday.
happily take Tuesday.
Take that.
Yeah.
And then those ones that are done, we'll say, you're so good.
I was gonna say for Friday or Sunday.
I like Tuesday and Thursday. I don't know. It's just easier because you start getting on those weekend days and
Well, and I think that's really what messed me up with everything that happened to me last week was for some reason I was just thinking, okay, Tuesday or Thursday.
Mhm.
And I sat down last night to look at things thinking it was due today.
Mhm.
And I was like, oh, I was supposed to have that done Friday. Oops.
Well, I knew that we would have some issues with changing everything. It's hard enough, it's weird because people try so hard to keep on top of everything. I know they do, but it's just so hard to keep on top of everything when it doesn't change. And then when it's changing, it's just like,
I was helping with work for skills over in Graph
Uh-huh.
Hall, and just basically doing gopher work, things like that. They wouldn't let me into the rooms when testing was going on in the event that I had to take the test at a later point. But I did all the prep work. I put all the computers together over there for them and everything. And Thursday morning, it was just hectic. Everybody was just running around like everything was on fire or something.
This contest makes it that way all
Yeah.
the time, I guess, no matter how ready you are. And silly snow days and all the running
There
around.
was a second delay too, because the first test date was delayed because of weather, and then they decided we had classes on that Wednesday that were supposed to be canceled, and this room I guess was going to be empty that day at the time, anyways. Well, because of impending weather, schools in the district may not have been able to get here. And then we thought we were going to be closed, so we closed campus because Springfield schools closed, and everything got moved. And then we almost closed it that Thursday too.
Really? Did
Yeah.
we have more snow that day? I don't even remember.
There was snow in the outlying areas, but they talked to the participating schools, and I guess everybody felt that they could do it.
Not worth changing again.
Well, yeah, because it would have been sometime this week, where we already had a short week. So it would have been like today or tomorrow.
Killer.
And it's
Crazy. Okay.
I don't
Well,
think
I'll
this
see you next week.
computer's broken.
Yeah, it's not. Somebody was sure it was. So they left their sticker. I was like, oh, okay. It seems to be working. You know how they'll be like, well, because I think it was like updates. And I kept saying, well, have you restarted it? Because it probably needs to be restarted. And after we restarted, it was fine. And so I was like, I don't think it's broken. He stuck it on the back because he was pretty sure it was. It's going to be a matter of time before I realize it.
I was looking at it and I was like, I'm positive I saw somebody working on it.
It was not broken. But he was sure it was. And these little ones can do weird things like one of the ones over there the other day started that beep. The power supply, I guess, has to be reset because these little bitty baby power supplies. And so it's beeping and flashing amber, and they were telling me how it was broke. And so it came back on. It was fine.
Both like and despise these things.
Me too.
Great for a classroom setting like this. But what I dislike about it is because they're so small. If something goes wrong, you're basically just replacing the whole.
Right. There's no parts.
I think there's like 4 user replaceable parts inside there.
That's why honestly, that was my motivation years back to get out of teaching PC maintenance, because I said, I see PC maintenance being the same as TV repair, that there's not going to be jobs. Their network support for sure, lots of jobs, desktop support, but as far as repairing hardware, just going away. And that was the funnest part of teaching PC maintenance. All that other stuff is so boring.
Yeah.
But when you got them into the hardware, then it was fun, you know?
You can see the lights click.
Yeah, it was fun.
Oh, I get this.
But I was like, I can't teach this anymore because it's going to go away and I'm going to end up teaching something that doesn't exist anymore.
I'm doing DA plus certification tests.
Uh-huh.
There, which are now Net 107 and 108. And I've been in the field for 20 years. So, I mean, I'm flying through the course because we're going over things that I know and actually know now.
Mm-hmm.
And my instructor accidentally had a slide up about Mac OS. And we had a shipment of Cisco networking equipment get over there that they had to get out of the rain. It was raining. So my boss came in and talked to my instructor and said, I wouldn't normally ask, but we've got to get at least $500,000 equipment outside in the rain. So we've got to get it inside. So we borrow Zach and John, who are the work studies, to. So I go out there, I'm moving things around before class starts, and then I go in to explain to my instructor what's going on in the class. And he's got this Mac OS slide up. And he says, I don't think you're going to have any issues missing anything. You're doing perfect in the course. And I said, yeah, I don't mean to brag, but I'm pretty comfortable with Mac OS. And he gives me this look, and then one of the other persons in the class says, yeah, he worked for Apple for 6 years. And he said, really? You did? Yeah.
He's got it. He's got it.
6 years with Apple. You get very familiar with it.
Yep. Got it. So are you just going to go through the whole course before you take your A+ though?
Yeah, I'm going to go through the whole course. Basically, I need the credits because of everything that happened to me last semester. I've got to have that participation rate stay up for any financial aid, otherwise everything's coming out of pocket. And while I don't necessarily need grants and scholarships, they help. Yeah. So.
Yeah, well, that would be a good one. I mean, I think it's unnecessarily hard. I think they're getting
Yeah. I see something just work. It won't be a big bomb. Oh, it's so close to it.
Yeah. I'm staff that Microsoft just you know, that was a good way to introduce risk and all the certification theory. Before and everything. That's how I got my certification for this 2000 server.
It's just terrible. I am so glad that I'm here and not there anymore. It's just a lot that you know, now it's just hard.
Yeah.
For everything. Because I was just glad I lost her. You know, anything I did, and I could do anything that I wanted to, because I would be able to get this off there. So, and I mean, I know it's still out there. It's just a lot harder than it used to be to get it.
I've never been enough to get up, but
Oh, yeah.
yeah, more than nothing. There's such candy. When I say kid, I think you might be surprised if I and he's a nice guy. He's just
He's not. He's always.
I know how to use it. I don't know how it works, and that's where he's at. And it doesn't matter how good basic is explaining it. It just doesn't make sense.
There's just some people that are that way. I had one once he always had to know how everything worked. And I mean, like a hard drive. How does that work? How internally? And I finally was just like, you know, some things you just have to use.
Well, I have found the analogy that I don't have to understand the inner workings of an engine to know how to drive a car.
Exactly. And some teenagers really suck. And they can't.
Yeah. Spent 15 minutes yesterday talking about storage and cooling storage for allocation company aircraft setting. So we had this visualization chart where we had 4 buckets of 3 terabytes of storage, but we had 8 computers that were all dedicated to storage to those 4 buckets. And a couple of questions were actually there. I said, think about it. And my instructor gave me this funny look. I said, just listen to what I have to say. Everybody everybody in the room wants pizza. I got $5, the next person's got $2, somebody else has got $12, but we want to buy enough pizza there. We can either buy enough for just us, and that's all we get, or we pool everything together, we can make one big order, we can get several pizzas, and then we get as much as we want. And then we'll go, oh my gosh.